Today we will be looking at vertical stretches and compressions. To begin, let's discuss what a vertical stretch or compression is. So this is when we're graphing y equals a times our function. So the function y equals a f at x is a vertical stretch or compression of y equals f at x. The a indicates the factor the function is vertically stretched or compressed. So if our value of a is greater than 1, the function is stretched vertically. So what that's going to look like is going to look skinny compared to our base function. And when we're looking at our function where a is between 0 and 1, the function is compressed vertically. And visually that's going to look fat. So when we're graphing these type of functions, we need to make sure that we're looking to see if our value is greater than 1, and also, or if it's a fraction, okay? Because if it's between 0 and 1, we know therefore it will be a fraction. So let's go ahead and sketch a couple of the functions. So we'll begin by sketching our y equals x squared, which is our base function. So we can plot our point 0, 0, 1, 1, and 2, 4. And similarly on the left hand side of our origin, so negative 1, 1 and negative 2, 4. Connect our points there and make sure that we do label. So that's our y equals x squared. And now from there what we're going to do is we're going to look at our next function, y equals 2x squared. So what is that 2? Is it going to be a vertical stretch or compression? Since our 2 is greater than 1, we know therefore this is going to be a vertical stretch by a factor of 2. So when we graph this, it's going to look skinny. So what is going to happen here is our vertical stretch and compression, it affects each coordinate, and it actually affects the y coordinate of each point. So looking here, our origin's not going to change, okay? But our point here, 1, 1, you're going to multiply the y value by 2. So now it becomes 1, 2. Similarly, instead of our point 2, 4, you would multiply it by 4 by 2, and it would become 2, 8. So it would be somewhere pretty high up here. And similar on the other side, instead of negative 1, 1, it's going to be negative 1, 2, and negative 2, 8. So when we graph this, what you can see is that it's going to look long and skinny compared to our original graph. Next we're going to graph our other function here, which is y equals a third x squared. Now when we graph this, we're going to do the same thing, but what does that third do? That third is going to create a vertical compression by a third. So instead of multiplying by 2, you're going to multiply each y value by a third. So our origin's still going to stay the same at 0, 0, but now our point from being at 1, 1 is now going to be at 1, a third. And our point that is at 2, 4 is now going to be multiplied, the 4 is going to be multiplied by a third, which is actually going to be 4 thirds. Similar on the other side here. and we can connect these. So you see that we have a vertical compression here where it's going to look short and fat. So now let's look at our next functions here. So we need to sketch all of these on the grid. So our first one is our base function of y equals our root of x. So this is a root function here. So we can graph that point here, or sorry, that function. So we have the function at 0, 0, 1, 1, and another key point would be 4, 2. And the reason we choose those points, recall, is because they are perfect squares and therefore easy to solve. So this is our y equals our root of x. Now from there, we can go ahead and graph our y equals 3 root x. Now 3 root x is going to have a vertical stretch by 3. So again, that's going to make it look skinny, okay? Long and skinny. So we multiply each of the y values by 3. So the point 0, 0 is going to stay as is. The point 1, 1 is now going to become 1, 3. And the point here that's at 4, 2 will now become at 4 and multiply the 2 by 3, so 4, 6. And now we can graph our y equals a half root x. So what is that half going to do? That half is going to have a vertical compression effect by a half. So each of our points, the y value is going to be multiplied by a half. So 0, 0 is going to stay as is, as 0, 0. Our point 1, 1 is now going to become 1 half. And our point that is at here at 4, 2 is now going to become 4, 1. And we can connect those and label y equals a half root x. And that is our functions graphed. Now what happens when we have a graph that looks like the one below here? F of x is shown below when we want to sketch the graphs of g of x equals 2 f of x and h of x equals a half f of x. So to do this, what we need to do is you're going to take each point and you're going to apply the vertical stretch or compression to each point individually. So what we're going to do here is look at our first point, and that here is right on our axes. So that point is going to stay the same. So since it's 2 f of x, you're going to multiply all of the y values by 2. So this point here is -3, 2. So we're going to multiply that 2 by 2. So it's going to be -3, 4. This point here, that is at 0, 4, multiply the 4 by 2, and it's going to be by 0, 8, which would be somewhere about up here. Our graph's not quite big enough. Now this point down here, that is at 2, -1, is now going to become 2, -2. And this point here, which is at 4, 1, is now going to become 4, 2. And then we can just go ahead and connect those points. So it would be best if you did use a ruler to do this linear piecewise function. And that is what our function looks like for g of x. So now we want to look at our h of x, which is a half f of x. So again, looking at the given graph here of f of x, we're going to take each point and multiply it by a half. And remember, when we're doing our vertical stretches and compressions, it only affects our y value. So our point here is going to stay as is, right on our x-axis. This point here at negative 3, 2, multiply the 2 by a half, so now it's going to become negative 3, 1. This point here that's at 0, 4 is now going to become 0, 2. The point here at 2, negative 1 is now going to become 2 a half. And our point here at 1 here is going to become a half. Now we can go ahead and connect those points. Again, if you have a ruler, please use it. So you notice that one has been compressed. It looks a little bit shorter and fatter. Now what we're doing is we're looking at two different functions, f of x and g of x, which are shown below, and we want to write an equation for our g of x in terms of f of x. So just so we can visually see this a little bit better, I'm just going to trace our f of x here. Alright, so that is our f of x, okay? So we need to look at what happens to our values. Okay, so looking here at this point here, what we have is negative 4, negative 3. Then when looking at the g of x here, the corresponding point is going to be negative 4, negative 1. Now when we look at the other points on the graph, you notice that they are fractions of the other points. So we look at this point right here. This is at negative 1, negative 2. This point here is in between 0 and 1. So we know it's some sort of fraction. So looking back here, how could I get from negative 3 to negative 1? That's right, we can divide by 3. So if we're dividing by 3, therefore we're multiplying by a third. So therefore g of x is equal to a third f of x. So we therefore have a vertical compression by a factor of a third.